Good morning, good morning. Tell me once your voice is clear. Okay.
Tell me once voice is clear. Okay.
So, Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So, if I am talking about the optics, that is the ongoing chapter, we have completed the majority of the portions. We have started from reflection, we have reached till refraction. In this lecture, we are going to nearly cover the last most important things. Okay. That is our lenses, spherical surfaces. About only, anyways, we have studied for the last two lectures only about refraction. That is the most important thing. Refraction should be very clear, and all the things are derived from there only. Okay, so let's begin. One of the most important section of ray optics. Okay, and let's learn something new. Be ready with your pen and paper. Let's start without wasting any further time. Okay. So last class, if I've told you, we have studied about refraction from the slabs. Okay, from firstly we have studied from the single surface refraction, and going from denser to rarer medium, rarer to denser medium. All these things we have already studied. But in this lecture, what we are going to study, not about plane surfaces, we are going to study about spherical surfaces. And from these spherical surfaces, we will be deriving about lenses. Okay, we'll be deriving about lenses. Correct? So let's start. See how the derivation is going to be. How the derivation is going to be. That is important. That I have to tell you. See, let's suppose here is an object, and here is some spherical surface. Okay, spherical surface is here. Okay, no one side is polished. That means what will be happening? Light will be coming here. Okay, light ray will be coming here, and this will be the normal passing from the center of curvature. This angle, let's suppose theta. Some reflection will be happening, some bending will be happening, going from rarer to denser. That means this should be the original ray, but it will bend towards the normal. It will bend towards the normal. That means normal reflection. If there is normal reflection, can I say Snell's law is valid? Correct. Can I say Snell's law is valid? What I will say for Snell's law, I will write n1 sine of theta 1 is equals to n2 sine of theta 2. Exactly. This is what I am going to write. Now, what I have to tell you that use two relations for writing theta 1 and theta 2. Now understand, just as same as the mirror formula derivation I have told you, na, using the property of a triangle, here also you use the property of the triangle. How you will be using? Tell me, can you write angle of theta 1 as exterior angle property? Angle of theta 1, if you have to write, how you will be writing? Angle of theta 1 can be written as alpha plus gamma. Alpha plus gamma. This is the equation 1. And second one, if I will ask you to write beta, how you can write beta? This angle beta. Beta, can you write it as theta 2 plus of gamma? Theta 2 plus of gamma. Correct now? Now see how I am going to substitute. See, n1 sine of theta 1. Theta 1 is how much, students? Theta 1 I can write alpha plus of gamma. Alpha plus of gamma. Theta 1 is what? Alpha plus, oh, sorry, alpha plus beta now. Alpha plus beta. In this triangle I am taking, in this triangle, alpha plus beta. Alpha plus beta. Now correct. Is equals to n2 sine of theta 2. How will be writing, student? Theta 2. This is the angle theta, and here we have written about theta 2. Theta 2 I can write simply as beta minus of gamma. So write it beta minus of gamma. Beta minus of gamma. Now all these rays are always, I have told you that all the derivations that we do for paraxial rays. Paraxial rays means if angles are very small, I can write sine theta is equals to theta. That is what I can do here. I can write the sine of alpha plus beta is equals to n1 simply alpha plus beta, and here I can write it is equals to n2. At the place of sine, I will remove this. I will write minus beta of n2 into beta minus gamma. Simply I can remove because I know the property. If the angles are very small, this is the scenario that I will be having. Correct. Now further, let's see about it. How you can write? Take the beta things on one side. That means how you will be writing? Here you will be having n1 alpha, and take the plus of n2 gamma, and on the other side write here n1 beta, here n2 beta. Take it here. That means n2 minus n1 into beta. I've rearranged the same equation and I've written in some other form. Now let's see how further I can write about it. See, Now, the property of small angles is what? Theta can be written as sine of theta, and it can also be written as tan of theta. All these things are valid. So I will be writing now this alpha as tan of alpha. That means how I'm going to write it? Tan of alpha plus n2 I am going to write as tan of gamma, and here I am going to write n2 minus n1 tan of beta. Correct? Now further write it values. n1, अब बताओ alpha, this is alpha and you have to write tan of alpha. Tan of alpha, how you will be writing? You will be writing, sir, it is nothing but equal to perpendicular, that is mn divided by, this is the object distance, and I can say, can you see this distance is nothing but given as, directly I am writing u. Correct? Now c plus what is now gamma. Gamma how you will be writing? Gamma you will be writing perpendicular n2 into perpendicular, that is mn divided by the base how you will be writing? This distance of the image is given as how much? V is equals to, now here what you will be writing? Tan of beta how you will be writing? n2 minus of n1 is equals to gamma beta, how you can write? mn divided by this complete distance of center of curvature. This is the distance that you have to write. Can I say it is nothing but the radius of curvature? This will be the radius of curvature. Once check it somewhere, some calculation mistake is there, I think. Check the complete solution. It can be simply written as theta 1 can be written as alpha plus beta. Here it can be written as into theta 2 can be written as beta minus gamma. Correct? n2 gamma will be coming here. Correct. And one, then you have written tan of alpha, and here you have taken n2 beta, and here you have taken minus of n1 beta. Correct? So now what will be happening? mn will simply get cancel out. Now I don't have left any space here, so let's see here. See, see, there is no space here, yeah. Let's write here only the derivation that I have spent till here. You have noted it down. Now the final generalized way how you will be writing the derivation is same thing that you have written. U distance that you have written. What was the final thing that was coming? Let's again write it. It was coming n1. Tell me what was the final thing that was coming? If I am right, n1 plus n2 by v is equals to n2 minus n1 divided by r. Correct? Now what you can say, that direction of incident ray is taken as positive. That means this u will become what? Negative. If this will become negative, what you can say? n2 by v minus n1 by u is equals to n2 minus n1 divided by r. This is the result, final result that you have to remember. This is the final result that you have to remember. Is it clear? So better way for remembering the same result, I will tell you, don't remember like this way, n1 n2. I've always tell you that don't remember the formulas in terms of n1 and n2. Always remember the formulas in terms of incident and reflected. So same formula how you'll be writing: n of refracted medium divided by v minus n of incident medium divided by u is equals to n of refracted minus n of incident divided by r. This is the formula that you will be writing or remembering always, because this will not create any kind of confusion at any single point. Let's suppose multiple refractions are also there, then also the formula will be very much clear to you using this method. Clear? So don't go for the n1 n2. Simply here is again the complete derivation is given for you. So let's apply this in a formula, and let's see what is the answer, so that application is very much clear to us. See, read the question. An object is placed in a medium of refractive index n is equals to 1. Okay, object is kept in a refractive index of medium 1 in front of a spherical glass. Spherical surface is given. Of refractive index is also given. 1.5 refractive index is given. Find the nature and the position of the image formed due to the object. You have to calculate what is the nature and the position of the image. So how we can calculate the position? Let's see. See, what I will be writing the equation, nr by v minus ni by u is equals to nr minus ni divided by r. Correct? Now put the values. Nr, what you will say for nr? N of refracted medium. Can you say this is the refracting medium and this is the incident medium? This is the bisection point. So tell me, what is the refractive index of the refractive section? 1.5 divided by v. What is the position of image? That we have to calculate. Minus what is the incident medium? Air. 1 divided by u. U is what? This is the pole that is considered as 0, 0, and this direction is taken as positive. That means this direction will automatically become negative. That means I can say negative of 30 will be taken is equals to nr by nr minus ni. That means it will become 0.5 divided by, what is the radius of curvature? 10, and I will take it as plus of 10. Why? Because the radius of curvature is lying on the right side and it is calculated in the positive direction. Correct? Now see, what we will be saying, 1.5 by v plus 1 by 30 is equals to, here it will become 1 by 20. Correct? Take it here. What will be the calculation? Multiply 3 minus 2, it will become 1 divided by 60. That means v can be written as 60 multiplied by 1.5, or directly write 15 divided by 10. This will get cancelled. 15 into 6. 15 into 6 is how much? 15 into 6 is equals to 90 centimeter, and it is coming in positive. That means image is forming on the positive side. Image is forming on the positive side at a distance of v is equal to 90 centimeter. Now tell me, it will be real or virtual? I've told you, in case of, again I am repeating the same thing, in case of reflection, if the object is real and image have to form real, they have to be on the same side, because reflection is the pattern of light which comes on the same side. So for real object, real image you want, that means it should be on the same side. But in reflection is a pattern which transmits the light in the other medium. That means it travels into the other side of the whatever the reflecting surface that we have taken. So if there is a real object, for having a real image, image should be on the other side. That means if image is forming on the same side, it is real object, virtual image. I hope that this is clear to you. Correct? Very good. Now see, one more question. Let's see, to clear the sign conventions. Sign conventions are much important for us. Once you understand, I've told you, understand the sign convention, then there is nothing. See, what is the question? Rays coming from a medium of refractive index n is equals to 1.5. Okay, rays is coming from a medium where refractive index is 1.5. Seems to converge at a point O. It seems to converge at point O. Okay. In a spherical slab of refractive index is having refractive index 2 as shown. Find the nature and the position of the image form. That means, can you say actually these incident rays are meeting, or it is appear to meeting? I will say it is appear to meeting. If it is appear to meeting, that means what kind of object I am having? Real or virtual? Actually I am having virtual object. So what I will be saying, I will just simply apply my equation, that is nr by v minus ni by u is equals to nr minus ni by r. Right? Now, what is the refractive medium? 2. What is the position of image? Position of image, that is what you have to calculate. What is the incident medium? I will say this is becomes my incident medium and this will become my refractive medium. Now, what is the incident medium? Incident medium is 1.5 divided by, what is the position? Now, if this is the direction for incident ray, this direction I will be taking positive, this direction I am going to take as negative. Correct? So I will be saying that for calculating the distance of object, I have to go in the positive direction, and how much distance? 30 centimeter is equals to nr minus ni. That means it will become 0.5 eventually. And what is the radius of curvature? Radius of curvature is again given as 10. Clear? Sign conventions is clear. If there is any doubt in sign convention, any portion, please tell me in the comment section. Okay. Now just after that, it is just about solving purpose. So it will become 2 by v. Here it will be coming. Here it will become how much? Again 1 by 20. Here it will become 1 by 10, it will become 2. Again I can say it will become plus of 1 by 20. That means 2 by, that means it will become 2 by v is equals to 1 by 10. That means v is equals to 20 centimeter. V is equals to 20 centimeter. That image is forming on the other side at a distance of 20 centimeter. This is fine, but what about the nature? Will it be real or will it be virtual? क्या लगता है? See, now this time object and image are on the same side. That means they will be reversed. अगर object real है, in reflection only I'm talking. If object is real and image is forming on the same side, it will become virtual. But if object is virtual and image is forming on the same side, it will become real. समझ आ रहा है नहीं आ रहा है? Correct ना? So this will behave like a real image. What will be happening if it is forming on the other side? If it is forming on the other side, because it is a natural phenomena of reflection to pass the light on the other medium. Okay, so if the light is passing on the other medium, if this is virtual, here it will be forming again virtual. Virtual to virtual, real to real. If it is on the same side, it will be reversed. That's it. That is what we have to understand. Clear? Right. Let's move further. Two questions we have seen for the better application. Now here, what will be the formula of magnification in spherical surface? Let's understand. Okay. So on the surface, apply Snell's law. What will be applying Snell's law at this surface? This is a spherical surface. Okay, here is a height of object given. Here some images forming, distances are also mentioned. So write Snell's law. How you can write? See, what will be saying? N1 sine of alpha is equals to N2 sine of beta. N1 sine of alpha is equals to N2 sine of beta. So further can I say, if the angles are very small, I can write theta is equals to sine of theta is equals to tan of theta. Every place I am using this. So I'll be again writing that in the same manner. So I'll be writing here N1 tan of alpha is equals to N2 tan of beta. It is equals to tan of beta. So further I will be writing this as, बताओ, tan of alpha how will be writing? Tan of alpha perpendicular upon base, that means h0 divided by u is equals to tan of beta. How will be writing? It will be N2 tan of beta. Beta will be written as hi divided by the distance of image, that is v. Correct? Now see what you can do. Height of image divided by height of object. This is defined as what? Magnification. Yesterday I have told you this is defined as what? Magnification. And if you are taking height of image, height of object, take it here. You will be writing what? N1 by N2 into V by U. And but how? I have always told you that don't remember the formula in terms of N1 N2. How you will be remembering this formula? N1 is the incident medium. That means you will be saying net final result of magnification is equal to Hi by Ho is equal to N of incident medium divided by N of reflective medium V by U. V by U. This is what you will be saying about the magnification formula. Correct? Very good. Let's suppose you have to calculate the velocity. Let's suppose you have to calculate the velocity. How will you be calculating? For calculating, this is the position of image. This is the position of image. Just for calculating velocity, what you can do, differentiate this equation. Differentiate this equation. Let's see what is the result is coming. That is going to give us velocity. Anyways, I've always told you that it is very simple way, and this is for longitudinal point. Okay. So if in transverse you have to write what you always write, magnification is equal to Ni by Nr is equals to multiplied by V by U. This is what? Height of image divided by height of object. Same formula will be going for velocity of image divided by velocity of object in case of transverse. In case of transverse, and in case of longitudinal, what is the formula of magnification is that V you get, that is Ni by Nr V square divided by U square, and it is written as what? Hi by Ho. Same formula will be going for velocity of image divided by velocity of object also. That means velocity of image can be written as Ni by Nr into V square by U square into velocity of object. And the same thing I am again going to prove here also. Let's say differentiate this equation with respect to time. What will be saying? N2 differentiation of 1 by V differentiation, that means V power minus 1, take it down, 1 by V square it will become, that is minus term will be coming here, and differentiation will become V square dV by dt. That means the rate of change of position of image with time, minus. Here already minus is there, that means it will come plus Ni into du by dt. Here it will become U square, the differentiation. u square, and differentiation of r will become 0 because it is always constant, it is not changing, it is fixed. Okay, now take it on the other side. What you'll be writing at the place of n1, I am writing n of incidence directly, and u squared du by dt is equals to uh, n of reflected divided by v square into dv by dt. This is what the equation you will be getting, correct? Now do what you can write for du by dt, rate of change of position of object. What you'll be defining, this is defined as what? Velocity of object. Ni divided by u square into velocity of object is equals to nr into what is dv by dt. This will be the rate of change of position of image. That means I will write it as velocity of image, velocity of image. So how I can define it? Will become same thing, velocity of image. Finally you can say of velocity of image divided by velocity of object is equals to ni divided by nr into v square divided by u square. And can you say exactly the same thing that I have told you here also? Exactly the same thing that I've told you here. That means for longitudinal magnification, if the formula for height of image divided by height of object is equals to ni by nr v square by u square, same formula will be coming for velocity of image divided by velocity of object, ni by nr is equal to v square by u square. So in both the cases you can use. Now it's up to you. Clear? I've told you for both the ways. Correct. So this much we have to understand about spherical surfaces. Majorly we study about spherical surfaces for understanding the length. Why I am telling you to for the understanding of length? Because spherical surface is the point which gives you the derivation of length. Okay, how will be that? Because length is made up of two spherical surfaces. If you'll understand, if you have watched the length, of course you will have watched the length in your colleges, or if you have not watched, please go and watch. Okay, perform some light experiments with that. For if I will tell you about lens, if I am talking about conventional lens, it is curved like this. So this portion is a part of one spherical surface, and this portion is a part of one spherical surface, and when it is combined of two spherical surfaces, it forms a lens. It forms a convex lens. Okay, for example, same with concave lens also. Here it is the concave lens. It is again a part of two spherical surface. See here, what is the definition? A lens is a piece of transparent glass which concentrates or disperses light when passes through them by reflection. Okay, and there should be minimum at least one surface of the lens should be spherical. Then only it is called as lens. This is the basic definition. Some important points. These are theoretical things that you can study from your books. Some important things that I have to tell you. What are the varieties of lens? There are lots of varieties of lens. Biconvex, if I'm talking about convex lens, biconvex lens, where both the radius of curvatures are equal, r. Then there is convexo convex lens, concavo convex lens, plano convex lens. All these things are for lens. Same goes for concave lens also. Biconcave lens, concavo concave lens, convexo convex lens, plano convex lens, concave lens. All these are the varieties of the lens. Okay, so what are the important things that I had to tell you is, see, for understanding, for differentiating just by looking at the shape, that how you can differentiate between a concave lens and a convex lens is what? Convex lens is always thicker from middle. Convex lens was always thicker from middle, and concave lens will be thinner from the middle. For example, see here, one more important thing. If you have to judge that what is the net property of this lens, so always study the last one. What is the name that is given in the last term? That is concave lens. That means the net behavior of this lens is going to be a concave property. Okay, this will judge. That means net, it is going to be concave lens. See here, it is thicker from the edges, but here it is thinner from the center. What is the no, this is the convex lens. Then net property is going to be convex, because I will always watch the last name that is attached with the this is the nomenclature basically. So it will be looking like thicker from the middle and thinner from the edges. See, judge here, it is thinner from the middle and thicker from the edges. That means what kind of lens it is? It is concave lens. Here you can see it is biconcave lens, or a concave lens have different varieties. Here, tell me what kind of lens it is? Thicker from the middle and thinner from the edges. That means it is net, it is kind of convex lens. Now convex lens also have lots of varieties. Now it depends on the radius of curvature. It is plano concave and what kind of concave it is. Clear? See, this is the way how the lenses are formed. You can see center of curvature is the center of the sphere from which you are cutting it. Radius of curvature are the radiuses from where you are cutting the from you are creating the lenses. Optical axis, this the axis, that is the line joining between the two center of curvature, is called as optical axis. Okay, these are some basic and points that you should be knowing about. Here about thin lens, actually we are going to study thin lens. Thin lens means what? The thickness that we are having between the two surfaces of the lens is very negligible. For the calculation purpose, of course, for the derivation we always try to calculate the ideal scenario, so there will be some negligible distance still, but we'll be neglecting that. That's why we derive everything for thin lens. Okay, these are the two varieties of lens: concave lens and concave lens and convex lens. Now if I will telling you some important properties, anyways I will be proving that focal length for convex lens is always positive and focal length is for concave lens is always negative. In a specific condition, there is only one case where it will be reversed. I will be telling you about that case. So it is not universal. I've told you. It is always also represented by this sign. This is the converging sign, because this is called as converging lens. This is called as what? Converging lens, and this is called as what? Diverging lens. This is called as what? Diverging lens, and the representation for this kind of lens is this way. This is a representation, just representation terms. If somewhere if it is given, so you should be understanding about the representation as well. समझ में आया? चमका नहीं चमका. Our teacher used to say चमका नहीं चमका. So tell me, chamka nahi chamka? See, next case. Now let's come to the lens maker formula. How will we deriving lens maker formula? That's why we study about spherical surface majorly. Okay, to understand lens maker formula, let's see how we can derive the lens maker formula. See, this is the principal axis. Here is your object. Again same kind of things. Distance of object from the pole is given as u. The distance of image is given as v. This is the incident medium, this is the refracting medium, this is the lens, this will be the pole, this is principal axis. All those things are same. Focus is again same. If light rays are parallel, it is going to pass from the focus. Anyways, ray diagram also we are going to see, but this much of basics you have already studied in your class. Okay, see what I can do. Firstly, light rays are coming. This is the object. Light rays are coming and it is incidenting on the first spherical surface. Okay, first spherical surface. Let's combine. Let's see one by one. What you can write about first spherical surface? You have seen the formula of a reflective spherical surface just a few times back we were discussing. What is the formula for reflecting surface? Nr by V minus Ni by U is equals to Nr minus Ni divided by R. Correct? So let's apply this. What is the incident medium? This is the incident medium. This is the refractive medium. Now let's apply the formula. What will be writing? Tell me. Here this medium is given as Ns. That medium is also Ns. So sorry, but light is not coming into this medium. Firstly, light is coming into the lens medium. This is the lens, and the refractive index for the lens is given as NL. Only focus on this first surface. Initially, it is incident from here, incident medium, and this is the refractive medium for a moment. Now write the equation. What will be writing? NL divided by first image. Let's suppose here the I dash is forming. I will write V dash, that is the first image position, minus incident medium is what? Ns, divided by U, that is the position of object, is equals to NL minus Ns divided by what is the radius of curvature for the first spherical surface? R. This is the first equation. Any doubt? Any doubt? Koi gila shikwa? Chamka? Now let's write the second one. Second spherical surface. Now light is coming from here. I should change my color. Now light ray is coming from this lens medium to the surrounding medium. That means I will say this will become now incident medium and this will become now refractive medium. Now tell me how I will be writing the equation. NR, that means refractive medium. I will write Ns divided by final position of image V final minus of incident medium is what? N of lens divided by what is the position of object. Now can you say this I dash will behave like an object? What is the distance that I have taken for this as V dash is equals to ns minus of nl divided by r2 divided by what? R2. Clear? Now see these two equations. Now it will be coming down to solving. See, I am not interested into this intermediate image. You tell me, sir, that just applying single formula, I don't have to perform these two times of refraction. These two times of reflection I want to skip, and I want a direct formula. So what I can do, I will skip this intermediate image that is coming. I'm interested in the initial object and the final image where it will be forming. Just tell me that only. So what I'll be doing from equation and 1 and 2, I will eliminate this v dash. How I will eliminate? I will just simply add up them. If I'm simply adding up them, what is the equation that is coming, students? I will say ns by vf minus ns by u is equals to here what you are getting, nl minus ns will be taken as, and here it is taken because here it is nl minus ns and here it is ns minus nl, so I will be taking it as common, and here it will be 1 by r1 minus 1 by r2. Can you say this will be the equation that will be coming? Now I am further writing it here. I can write this equation as, take the ns common and take it here in down. Take this ns at here ns. So what will be there? 1 by v final minus 1 by u is equals to, here it will become what? nl divided by ns minus 1 by r1 minus of 1 by r2. This will be the final result that you will be having. This is the final result that you will be having. Is it clear? समझ आया? Now what are the terminologies? This is actually the length formula. This complete is called as length maker formula, but if you know, this complete term is nothing but what? 1 by focal length. This complete term is what? 1 by f. If you know, in the basic classes also you have studied a little bit of formula, you know that length formula is 1 by v minus 1 by u is equal to 1 by v minus 1 by u. This complete term is nothing but 1 by f. This is what is length formula, from where we are going to derive all the positions of image. Clear? समझ आया? How to derive? फिर से खुद से करना, you will be getting the things. So what is focus? I have already told you. Focus is the point. If the object is kept at infinity, some parallel rays will be coming and it will be converging at the focus. Let's prove this also. कहाँ गया our pen? The length formula that I am having is 1 by v minus 1 by u is equals to 1 by f. If the object is kept at some infinite distance, that's why parallel rays are coming. So I will say here it will be tending to infinite. 1 by infinite is equals to 0. That means v is equals to what I will say? Position of image is equal to focus. That means position of image is equal to focus. Clear? So bus, this is what it is. Clear? Now there are from this formula only we will be judging the different cases of a lens. Okay, let's see. But before judging that, let's apply the formula and let's see how we can apply the sign convention, because I have told you that sign convention is the biggest game. Sign conventions नहीं समझ में आया तो मतलब कुछ भी नहीं समझ आया. See, let's how I can understand sign conventions. अरे पेन कहाँ है भाई? Calculate the focal length of the concave lens of the refractive index 1.5. Okay, kept in a medium is there, that is kept at 2. The radius of curvature of the spherical surface of the lenses are 20. This radius of curvature for the first surface is 20 and the second surface is 10. And we have to calculate the focal length. What is the formula for focal length? Just write it again. 1 by f is equals to n of lens divided by n of surrounding minus 1 by r1 minus of 1 by r2. This is what the complete formula is. That means now just put the values. What is the refractive index of the lens? It is 1.5 divided by. What is the surrounding refractive index? Surrounding refractive index is given as 2 minus 1 by r1. Now how I will be taking r1? I will be conventionally taking this direction as positive. Okay, I will assume that some object is kept here and I will conventionally taking this direction as positive. That is for now assume this is the spherical surface. This is a spherical surface. कहाँ पे इसका center lie करेगा? Where the center of this will be lying? On the left side or on the right side? Tell me, on the left or the right? Left or right? It will be lying on the left side. Somewhere here. I don't know the exact position, but it will be lying somewhere here. And I know the position as well, actually. So I will be saying for calculating this R1, I have to go in the positive direction or in the negative direction. Actually, I have to go in the negative direction. So I will be taking this value as negative minus of 20. Correct? Now minus 1 by R2. Now tell me about R2. What you will be writing about R2? This is the R2 10 centimeter. But for this, where the center will be lying, on the left side or on the right side? I will say this time the center is lying on the right side. Center is lying on the right side. So I will be writing it. It is lying on the right side. So I have to calculate this is in positive. So I will be writing here as 10. This is what I have to solve. Okay, fine. Let's solve it. It will become how much? Here it will become minus of half divided by 2, that means minus of 1 by 4, that is already here. Here it is minus of 20, here it is minus of 10. यहाँ पे क्या होगा? Take the LCM. Here it will become minus of 3 divided by 20 and here minus of 4, cancel. Here you will be having what? It is equals to 1 by f. So f can be written as 80 divided by 3 centimeter in positive. Sir, you have told me just few moments back that concave lens is having focal length negative and convex lens is having focal length positive. But why you are having the result as positive? Why you are having the result as positive? That is the thing that I have to explain. I've told you there now that I'm telling you this, okay, fine, but there is an exception case. Now in physics there is no exception. I will prove that. Okay, I will prove that. As of now I have told you there is a exception case actually where this will be getting reversed. And what is that case? I am telling you. Okay, let's understand. But before that, there is one more question, or you can try it by yourself. Only thing that you have to be careful, or let's try it. You can try it, but only I have to tell you here, all the values are again given. Just same way, put the values one by one, you will be having your answer. Only thing that you will be taking here is this radius of curvature that is going to lie on the right side. You will be taking this as 20, but plus of 20. But what about this plane surface? What is the radius of curvature of a plane surface? We take it as infinite. Okay, because we assume that at some infinite distance it is going to take a curve. That's why we define it as infinite. Correct? So this is what I have to tell you. Just put the value R2 as infinite. You will be having your answer. 1 by infinite will become 0, and rest of the things surrounding and lens refractive indexes are given. इतने देर में तो solve भी कर देता. See, now the question is for converging and diverging lens. See, now the question is for converging and diverging lens. Now understand what I am trying to say. And let's prove that also there is nothing like exception. ये क्या हो गया भाई? This actually is 1 by f is equals to n of lens divided by n of surrounding minus 1 by r1 minus 1 by r2. Okay. Let's understand firstly for convex lens. बहुत ध्यान से सुनना मेरी बात. Okay. Listen very carefully. I have to tell in the both languages. इतनी तो हिंदी आती होगी यार. Okay. Now see. Let's suppose a biconvex lens. Biconvex lens means what? Radii R1 is equals to R2. That is defined as biconvex lens. So in terminologies you will be reading them. So let's suppose R1 is equal to R2. Let's put it with the sign conventions, and I am going to break this complete section in this. This is due to geometry. This is due to the medium. This is due to the medium. Now see, let's firstly understand the geometry. Due to geometry in refractive index in the convex lens. R1, how I will be taking this? I will be coming on the positive side, so I will be putting here positive, minus R2. R2 will be coming in the negative side. This will be the center somewhere lying for this radius. So you will be taking this as minus. So can I say this is plus and this will become plus again? So I can say this will become positive. So I can say due to this geometry, it is always positive. This is due to geometry. This is always positive. So it have to be, if it have to be always positive. And so both geometry and medium have to be contributing in positive, and I've told you that it is converging lens. It is what? Converging lens. Now let's analyze this one also. See, most of the cases, n of lens will be greater than the surrounding. N of lens will be greater than the surrounding. The refractive index, because most of the time we are keeping it in here, and air refractive index is 1 and lens is always greater than 1. Most of the time it is 1.5. Okay. So if n of lens is greater than the surrounding, that means can I say this value is always greater than 1? Chamka nahi chamka. If n of lens, if numerator is greater, let's suppose numerator is 5 and denominator is 4, can I say it is net greater than 1? Clear? So I will say that always this value is going to be positive. Most of the cases it is going to be positive. And if it is going to be also positive, and this is always positive, that is positive, net it will become positive. net it will become what? Positive. Okay, but what is the case in which it will become negative only? That you have to understand. If this will give you dhoka, if this is going to give you dhoka, if surrounding is greater than the lens, if surrounding is greater than the lens, let's suppose lens is having, for a moment, let's assume 1.5, lens is 1.5 and the surrounding, just in like the previous case, it will become 2. Then can I say this value is going to be less than 1? If it becomes less than 1, less than 1 minus 1, it will going to be negative. Here it will become negative, here it will be is what? Positive. Negative into positive, it will become negative. That is the only case where you have to be careful, where focal length will become of convex lens, it will become negative. Okay. Otherwise, always conventionally, the focal length for a convex lens is always positive. Clear? समझ आया होगा? Now let's see the case of concave lens. What is happening in the case of concave lens? Let's understand. Concave lens, let's again take a biconcave lens and try to understand. What is the formula? 1 by f is equals to n of lens divided by n of surrounding minus 1 by r1 minus 1 by r2. Correct? Now see, again r1 is what? Negative, because the center will be lying on the left side, somewhere on this side it will be lying, so I will be writing it as minus of 1 by r, and both r1 is equals to r2 biconcave lens I am taking. Minus, now what will be saying about r2 will be lying on the right side, that means on the positive side, so it will become, again it will become positive. So I will say net what I am getting, minus of 2 by r. That means always this value, conventionally this geometry value is what? Negative. It is what? Negative. And here what I can say, if n of lens is greater than n of surrounding, that is most of the time, then the focal length is tending to what? Always negative. But what is the exception case? What is the exception case that I have to tell you? The exception case is what? If the surrounding by chance become greater than the refractive index of the lens, then it will become positive, and here it will become negative. Sorry, if the surrounding becomes greater, then it will become what? It will also become negative. This medium becomes negative if surrounding is greater. Let's suppose if that means it will become negative. This is negative. This is always negative. Negative into negative, it will become, focal length will become positive. Focal length will become what? Positive. Clear? समझ आया? So this is what the difference. Conventionally, naturally, if I will be telling you, most of the time, the refractive in the focal length of convex lens is positive, and focal length of concave lens is negative. Okay, and focal length and this concave lens is called as diverging lens. Convex lens is called as converging lens. I hope that this is clear to you. Okay. Now let's understand about the some conventional ray diagrams. Some ray diagrams are there. I'm telling you for converging lens. See, first one, ray, if ray is parallel to the principal axis, let's take the color also. First case, if rays are parallel to the principal axis, what will be happening? It will be passing from the focus. And you know now that in lens we take two focuses, foci, we call it. Here it will be center of curvature 1, center of curvature 2. Okay, so if light rays are parallel or in by this way also, then it will be passing from the focus. Simple. I hope that most of you will be knowing about it. Second one, if passing from the focus, if the light ray is passing from the focus, let's suppose light ray is coming and passing from the focus, that means after reflection what will be happening? It will become parallel. After reflection what will be happening? It will become parallel. If it is passing from the optical center, if it is passing from this optical center, that means it will pass undeviated. It will pass undeviated directly. That means this angle I is equals to this angle R. Okay. These are some basic properties that you have to understand. Clear? Same you can draw for this also. Now it will be your homework to draw this for a diverging lens. Again, it will be always also be having the. चलो बना ही लेते हैं. Let's suppose this is the. I have told you that this is the representation for diverging lens. First ray, if you are having a parallel to principal axis. Parallel to principal axis. Let's suppose this kind of rays are coming. So what will be happening? But it is a diverging lens, so it will be getting diverged from here. This kind of diversion will be happening, and when it will be making proceeding that, it will be forming the image at the focus. It will be converging at the focus. If the rays are passing from the focus, Let's suppose if passing from the focus, let's suppose what will be happening if the rays are passing from the focus, then after refraction they will become parallel. Pass it like this. Okay, let's suppose here it was coming and passing from the focus, after reflection red pencil draw kar lo bhai, this is the ray appear to pass from the focus, it will become parallel to the principal axis, and if it is passing from the pole, it will pass undeviated. This is the third ray that you have to understand. Is it clear? Is it clear? So this way we draw the ray diagrams also. So we'll be watching about ray diagrams in the next lecture. Until next time, keep learning, keep growing with Tapasya, Endigu and Dendigu Nama Tapasya.